Okay, good morning everyone. Thank you for coming so early after last night's party. I'm Spiros from the CERN Cloud. I was the PTL of Magnum for 4 releases, and this is the project update for Magnum. So what is Magnum? Sorry if you have seen this slide before or yesterday morning. Magnum is the REST API service of OpenStack. It uses Keystone credentials to orchestrate clusters of containers with Kubernetes, Docker, Swarm, or DCS. And it focuses on lifecycle operations and credential management like TLS certificates, X509 certificates, and the Keystone webhook that is only supported for Kubernetes at the moment. I will go quickly through the terminology in case that some people don't know about it. So to create a cluster, you need to have a cluster template. A very usual pattern is that the cluster admins create cluster templates and advertise them to users as public templates, and then the users can consume them, or advanced users can create their own cluster templates if the operators allow it in the policy. The cluster template includes information like what is the network configuration, if it has floating IPs, if it will have a predefined network or subnet, if a proxy must be configured for Docker to be able to pull images from Docker Hub or other registries, which network driver to use, which DNS server, and so on. Of course, also flavors, which describe the size of the cluster. We also have a labels field, which is string and it's an open-ended JSON. This has exploded recently, and we try to find a way to alleviate, to fix this issue. These labels can describe different aspects of the cluster, like tags or versions of various components that run inside the cluster. A cluster is the meta resource that lives in the Magnum database, but behind the scenes it's a bunch of Nova instances, some neutral networks, some volumes to extend the size, the available size for the Docker storage, and also a cluster in the Magnum database or in Barbican. There is a certificate authority that is used for the PK infrastructure of Kubernetes and for Docker Swarm. We support the 3 different engines that I mentioned, Kubernetes, Swarm, and DCS, but Kubernetes is by far the most popular. For example, contributors of Magnum Upstream use exclusively Kubernetes. They don't use anything else at all. There are multiple operating system options, which is like a usual friction point with users that they don't want to use the opinionated Atomic. CoreOS is also kind of supported, since we don't use it in our cloud, and we don't have many users actually using it, or only trying and see if it works or not. It's not very well supported. Also, there is an option to create VMs or physical machines, but this assumes that you have the ironic driver in Nova. So this is how the usage looks of Magnum. You create a cluster with a provided cluster template. You wait a few minutes, and then you can retrieve the credentials with cluster config, with a command OpenStack C cluster config, or if you use the old client Magnum cluster config. And then this command downloads the appropriate certificates, creates a kubeconfig file for Kubernetes, or just some environmental variables for Docker. And then if you source them, you can just start using securely the API of the orchestrator. And if you run, for example, kubectl proxy, you can access the Kubernetes dashboard, which is enabled by default. Some interesting work was done regarding this cluster config command, which is one of the highest values of the project. We added 3 options. One is output search, because the kubeconfig now supports embedding the search as base64 strings inside the file, so users can copy it around if they want to. Output certificates also output the actual files, because they might use them for we don't know for what, but they might want them, so we don't want to break them, and having them to take the base64 encoded strings and then create the files again. And then the use certificate and use Keystone options. Use certificate is to create the kubeconfig that I mentioned, and use Keystone is to create a kubeconfig file that uses the OpenStack token to talk to Kubernetes. And then, like I have shown here, you can export as an environmental variable the OpenStack token and then start using kubectl with your OpenStack credentials, provided that the appropriate role bindings exist in Kubernetes. Two community goals that we did. The most important was Python 3 first. All the testing that developers are doing since a couple of months, if they deploy DevStack, is with Python 3. Personally, I review all the code only with Python 3. I don't actually review test with Python 2, but the CI does. So we're very confident with Python 3 at this moment, thanks to the various Oslo libraries that help us with that. We also merged the upgrade checker framework. As many projects that have merged this is a no operation at the moment, but we'll try to come up with some checks for the next release to be more confident when upgrading and not just trust the community. Some generic enhancements that we did in the API. One of the most important was the Resize command. The Resize command replaced the old cluster update command, which was only allowing to change the node count. And in case of scale down, it was choosing based on some heuristics. And in the case of Docker Swarm, randomly a node to delete from Nova. But now you can pass either the UUID or the index, if it's 0, 1, 2, or 3 of the node, and then deletes only this one. And then you can also pass which is the desired count. So you, for example, you can remove one node, but at the same time increase the node count in total. This is like the declarative method of doing operations in Kubernetes. Then two more important additions, but this is mostly for operators to make it easier to advertise the project to users, is that the policy allows the cluster templates to be renamed. So you can have something, if you use Docker and Docker images, that you can have latest. So you can have a cluster template, which is always the kind of the recommended one. Usually it's the one that named just Kubernetes, and users just go there. And then to complement this, it's the hidden field that you can have versioned clusters, cluster templates. But when I say versioned, it's just a meta thing. It's a versioned in the name. And then when you don't want to advertise them, you make them hidden, like Glance has the community field, and like this, it's easier to advertise the project. Then we also added the node group API, which is to have different groups of nodes which have different flavors. I will talk about this feature later. But all the work for migrating the database and adding the APIs is there. At the moment, creating new node groups is an operation, so it doesn't have any effect. But in the coming weeks, we will confident that we will manage to have the final version of a new driver that supports this. For environments that have Octavia or Neutron LBAS or other solutions with LBAS, we added some pre-delete hooks, and with some improvements in the cloud provider, Magnum is smart enough to find which load balancers are created for a Kubernetes cluster, deletes the load balancers first, and then tries to delete the cluster and the nodes. Otherwise, it would be stuck. Deletion wouldn't work. Another feature that we added, which helps operators to check what's the status of the clusters, is the health status. So Magnum periodically asks the Kubernetes API, this is only supported for Kubernetes, if all nodes are ready and if the API is responding, and marks the cluster as healthy or unhealthy. Cluster resize I mentioned already. This was implemented very fast. It wasn't a very big change because all the underlying changes were already done before. And this is a pointer to the API reference with the payload if you want to use it programmatically. Git openstack.org is wrong, but it redirects to OpenDev now. This is how it looks from the CLI. You can do cluster resize, pass the name of the node group or not. At the moment, it goes to the default node group, the name of the cluster and the desired size. Or if you want to delete a node, you specify which UUID, which Nova Server UUID you want to remove, the name of the cluster, and the desired node count. Node groups. This picture shows the motivation of having node groups. So we have a master node group, which is already the case. It's represented by heat resource group. And then you want to have different worker node groups. For example, medium-sized VMs in different availability zones, some VMs with GPUs. For OpenStack, this is described by a special flavor. And in our case, and I think in many clouds, if you have the ironic driver, a different flavor will describe physical workers as well. This is how it looks if you do instine, list, and show a node group, but you cannot edit or touch the node groups yet. Autoscaling. This is a cool feature that was done actually outside the Magnum repo. All the work was done in the Autoscaler repo. And this implements just the interface that Google Cloud, AWS, Alibaba, and so on are implementing. At the moment, to scale up, it uses the Magnum API. To scale down, it uses the Heat API. But since we implemented the Resize command, not only for users, but also for the Autoscaler, we will use the Resize command and not touch Heat at all. And another important detail that you might not know is that the way that the Autoscaler now vendors dependencies, it's very easy to bump the Gopher Cloud requirements for Magnum and soon for the OpenStack cluster API implementation. I put this slide for the summary of all the Kubernetes OpenStack integration that we have. We have the out-of-tree cloud provider, which is much better with the in-tree and much more friendly to the OpenStack APIs. We have the Keystone Authentication webhook to use OpenStack tokens for authentication. We have the Octavia Ingress Controller for environments that have Octavia, the Magnum Autoscaler, which is for all Magnum deployments, and we just missed the Barbican KMS to do encryption at rest. But this is not very difficult to do. All the implementation and the cloud provider is done. It's just a matter of configuring and deploying it. Some additional add-ons. I will start from the bottom. We started implementing, this is not done, pod security policy. The default policy is not very restricted, so we wanted something more secure. And we will have two modes, one restricted, one privileged. And what is already implemented is the node problem detector, which is enabled by default to have better understanding what's the status of the nodes. And we have 3 ingress controllers, traffic, which is very simple in configuring, but it only allows HTTP, HTTPS, Octavia to use directly Octavia and Neutron LBus, and Nginx, which is useful for non-standard things, let's say, like TLS pass-through, which is not very modern, or exposing known HTTP ports, like, I don't know, port 1000. If you want to expose, you can do it with Nginx. Cluster healing is a very new addition, and we backported it already to Stein because we were a bit late in merging it. This is actually leveraging the Autoscaler. I have a very basic test on that, but it works. So if the node problem detector marks something as not ready, then Drano cordons and drains a node, and then the Autoscaler scales down the node because it sees that it's empty. It's a beta feature, so first test extensively. We could try to do the same as well. For cluster upgrades, it's going to be finalized in the next week or in the week after. The implementation for upgrading the worker nodes is done. We're just testing with Felon, which is the new PTL, to merge it. The API changes are done since a month or so, but we haven't merged them because we want to do it in one go. And this is the storyboard where you can follow all the work. Initially, the upgrade will be in place, and it will do a rolling replacement of the kubelets. And if you change the image of the worker nodes, it will also replace the VMs with new ones. Train goals that I'm going to talk about them also. We can discuss them in the project onboarding and hopefully tomorrow at the PTG. Short term is to finalize node group work, which we're very close. At CERN we have a working prototype. do some improvements in cluster upgrades because we wanted to have to merge very fast the first working implementation. And there are some improvements we can do. For example, be more graceful when draining a node, and try to implement some kind of policy when it's impossible to drain it fast. To do some heuristics or either notify the user or even stop the upgrade. And secret rotation. This is for security, but also comes because we're operators and we don't like errors in our logs, especially in Magnum, Keystone, or Nova, or Hit. So this is to rotate the trust user or the application credentials that we will try to adopt, and also try to rotate the trust users that Hit is using behind the scenes. Long term, this is also coming a request from Blizzard, for example, that they have their own driver. It's moving out of the drivers out of tree. This was tried 2 years ago, but then we lost a bit of manpower and we stopped following that goal. So instead of having them out of tree, we started having them in a contrib directory, which wasn't tested and it wasn't a proper setup. And as soon as we do that as well, we can also in parallel investigate the cluster API and have a driver behind Magnum initially, and then we can see if we need the Magnum API or not in the future. Instead of using Hit, basically use a Kubernetes to describe the cluster and the infrastructure. I will leave this slide here on how to give feedback. In case that you don't know, you can use OpenStack Discuss with Magnum. And the IRC meeting is in OpenStack containers, Tuesdays at 9 UTC. We are hoping to have more people from Asia and US. That's why the time. I'm in Europe. It's a bit unfriendly for me, but I manage. That's it. If you have any questions, otherwise, thank you. Questions? Oh, okay. Thank you.